Today in this video, we're going to be doing some Civil FE exam review, and we're specifically going to be focusing in on static. So I'm very excited for this video, and I want to go ahead and get straight into the content. So I have some practice problems for you all. So I'm going to make myself smaller, throw myself in this corner. All right, so I have open right now our practice problem and the FE manual and some space for me to do our problem. So first things first, I always start my videos by just explaining what we're going to be covering. So you will need to master each of these topics in the civil section. And today is our first day of statics. And so we're going to be doing a problem that focuses on the resultants of force systems. All right, resultants of force systems. So first problem, before I forget to mention this, if you have not checked out the engineering economics videos that I've made, the ethics or the mathematics, make sure you check those videos out. I go through every single concept. So if you want to have some extra practice problems and some like step-by-step follow along problems to do in your alone time, make sure you subscribe to the channel as well, because it will notify you every time I drop a new video. All right, so our problem, it says it's in the bottom right corner. It says find the resultant force for the concurrent coplanar force system shown below. So that's a lot of words, and I'm saying find the resultant force. So first thing that I like to do before I even start a problem is ask myself, can I use the FE manual for this problem? And being that I know that this is a problem that will be tested and this is a statics problem, I'm just going to come in here in my FE manual, do Control F, and I'm going to search statics, because I'm assuming that's where all the formulas are going to be for statics. So 21 different items come up. Okay, statics. Here's the formulas that I'll be needing for any problems that's acted on statics. So it says find the resultant force. All right. Okay. Resultant right here. The resultant F of n forces with the component Fx and Fy has a magnitude of this, right? It says the resultant direction with respect to the x-axis is theta, right? Okay. Resolution of a force. So this looks like what I need, but it's very important for me to be able to understand what this is. So I'm just going to write this in simple terms, all right, because this is a lot of sum of a bunch of stuff. So basically what this is saying is my F, let's see here, and please don't mind my handwriting. I promise you I didn't try to draw that F like that, but it is what it is. So my resultant force is going to be the sum of the forces in the x direction squared, and then plus the sum of the forces in the y squared, and all that is under the square root. Okay, that's all this resultant is saying. And if you know, like, what's the triangle, x squared plus y squared, take the square root of it and it gives you your resultant. This is the same thing, but it's just with forces. Okay, so now that we know that, all right, let's look at our problem again. Okay, so they drew out this complicated looking forces. So it looks like 200 newtons in this direction, uh, 90 newtons in a different direction, and 100 newtons in a totally opposite direction. So given all these forces, what's that resultant? So basically, you just want to break this problem up into smaller bite-sized pieces. So let's get all the forces, the sum of the forces in the x first and foremost. So I'm just going to break it up and sum of the forces in the x. And if I'm going too slow, feel free to speed through the video. I actually am not the fastest, but I find once I understand the concept, then I can move through the problems a lot faster. So sum of the forces in the x is equal to what? So you want to break these up into pieces, into like per force. So the first force we're going to look at is just the 200 newtons one. So to get the sum in the x, right? So you got this. I'm just going to draw this one force, right? It's 200 newtons. But we're looking for this force, right? This F of x, right? We're looking for that horizontal force that creates this 200 Newton total force, right? So that x is just going to be, to get that x value, is going to be 200 and then to get, we want the horizontal, so times 2 over, okay, what's so basically we're getting the cosine, so it's adjacent over hypotenuse. Well, we see, and I got 2 from, that's my adjacent value. What's my hypotenuse? Well, we got to do 2 squared plus 1 squared, which gives me, right, 5, and then take the square root of that. So it's going to be the square root of 5. And hopefully I explain that properly. Okay. So keep in mind that x value, since it's going in the positive direction, it's a positive force in the x, right? Okay, so let's deal with our 100 Newton force. And I'm kind of skipping around, I'm gonna erase that. Okay, so that 100 Newton force, we got a force coming 100 newtons, and we want to know this f of x, right? That force. So if, as you can see, that force is going in a negative direction. It's not going in the positive direction. It's moving to the left. So we're going to put a minus. It's a negative force. Okay, so minus 100 newtons. And then we're going to do cosine of 60. All right, they give us an angle this time from the x-axis, which is nice. So cosine is your adjacent value, which is going to be that x value, so cosine of 60. Okay, so erase that, and hopefully you get the point of how I'm selecting my directions and getting my positives and negative values. And so then we're going to do plus my 90. right? 90, and then cosine 45. All right. So we take all that, and this is a very key step. I'm using the TI 36X Pro. So it's very important that you know your calculator. But for this, we just want to make sure it's in the right mode. So this is why it's very crucial to be familiar with your calculator and, you know, really understand the concepts, because when you're on the test, this will be a breeze. Like you'll be like, okay, I know what mode to set my calculator in. I know how to do this problem. I know where to find the formula. It's just a lot more clear. So if you're using this type of calculator, just make sure you go to mode and put it in degrees. We're working with degrees here. If your calculator is set to radians, it's going to be incorrect. And so let's do the problem. 200. And I'm doing this with you so that, you know, it feels like you're actually working through the problem and I'm not just BSing. So I can feel some of your guys' pain and frustration. I took this thing enough times. So 100 cosine 60 plus. Okay, so I'm getting the sum of the f in the x direction is equal to 192.5. Okay, so hopefully that doesn't look like a, oh, that made it worse. Try that again. Definitely feel free to skip through if this is slow. All right. Still getting used to my pen. 192. And that's newtons. All right. Okay. 192.5. All right. The next one. The sum of the forces in the y, because we're not done yet, is equal to, okay, I'm going to do the same thing, but we're going to do it for the y's. So 200 newtons. This time we have a 1 divided by square root of 5. And then, all right, for the 60 Newton, that's a negative force. It's pointing downwards. My y is, anyways. So minus, or not 60 newtons, I'm sorry. For the 100 newtons, it's pointing in a downwards direction in the y, the y-axis. So it's negative 100. And then in this case, it's not going to be cosine because we're not looking for adjacent over hypotenuse. We're looking for opposite over hypotenuse. So it's going to be sine of 60. Okay, and then we're going to do another minus my 90 newtons. And again, it's going to be sine of 45. Okay, see what this comes out to be. So we had 1, divided by 5. Shit. 1 divided by and times that by 200 minus 100 sine of 60 minus 90 sine 60. Okay. All right. So I end up getting the sum of the forces in the y is equal to, from my calculations, I'm getting a negative 60.79. Could have just said 0.8. All right. So now we just want to take, now we want to get our actual resultant. Want to get our resultant force. So we're just going to say F is equal to this top formula, the square root of 192.5 squared plus, and then I'm just going to say a negative 60.79 squared. I'm going to drag this all the way out. Okay. So once we put that in our calculator, plus I'm getting my force, total force, or resultant force, to equal 201.8 newtons. Okay. And that is our resultant. And one other thing that I want to point out, if you're finding some value out of this video, make sure you hit the subscribe button and the like button to let YouTube know that this is actually helpful content. The second part to this problem is making sure that you know the direction, because they could very well ask you the direction for this. So to get the direction of this resultant force with respect to the x, right, after all these forces are coming in all these different directions, what is the result? What angle is that going to create as a result? And so that's the direction. So let's do it. I'm going to leave up. So to find the direction, it equals arctan of the sum of the forces in the y divided by the sum of the forces in the x. So that's easy enough. All right. So we have the sum of the forces in the x. We have the sum of the forces in the y. We know what arctan is, so we can do this problem. So let's erase. I'm just going to erase that resultant force. We know what that force is. All right, let's get the direction. So it just says theta is equal to arctan, and tan -1 is the same thing. So hopefully you know that. They're gonna put these symbols and stuff in the oddest ways so you don't, like, it confuses the shit out of you. But literally that's why we're doing these practice problems. All right. So yeah, the sum of the forces in the y divided by the sum of the forces in the x, right? Okay, and that just means equal to tan inverse 1 of 60.79 divided by 192.5. All right, see what we get here. So if you're using this calculator, you just want to double tap because tan is going to be, or tan is going to be the first selection, but to get inverse tan, you want to hit it twice. So you wouldn't know that, and you probably wouldn't be able to do that quickly on the test if you hadn't practiced. So just a little, hopefully a little gem there. 0.5. Okay. All right, so I get for my angle, that's an ugly angle, but you get the point, you get 17.5 degrees. So out of all those different forces, it's just going to be with respect to the x-axis is just going to be 17 degrees. So hopefully this was helpful. That is all that I think I have for you on this video. It kind of went longer than I expected it to, but before you jump off this video, I do have a few other things to share. First things being, be sure to check the description box down below because there are multiple resources there to help you pass this exam that you don't want to miss. Talking about discounts to courses, we're talking more practice problems, opportunities maybe to work with me, a bunch of stuff in the description box. So be sure to look at that. And I wanted to share that again, I do practice problems for every single concept. I'm over here hitting buttons that I don't need to be. But next we're going to be doing equivalent for systems, and that should be the next video that pops up. So be sure to click that. Thanks again for watching, and I'll see you all in the next video. Peace.